this video, I'll be talking about space telescopes. I mean, the telescopes that are out there orbiting the planet Earth. And I'll be talking about these space telescopes. Now, these space telescopes are the astronomical instruments, and they are placed in the outer space to observe the celestial objects. And these space telescopes are specially designed instruments that are launched into outer space to observe objects and phenomena in the universe. They offer advantages over ground-based telescopes because they are not affected by Earth's atmosphere. The idea of space telescopes emerged to overcome Earth's atmospheric interference. And the Earth's atmosphere can distort and absorb light and other forms of electromagnetic radiations, limiting the clarity of the observations. So, space telescopes were developed to bypass this interference and obtain the clearer images outside the Earth. The Hubble telescope is one of the most famous space telescopes out there. This Hubble is a renowned for its contribution to astronomy and its iconic images of distant galaxies, nebulae, and more. It has played a pivotal role in our understanding of the universe. And it was launched in 1990. The Hubble Space Telescope revolutionized our understanding of the universe. This Hubble's launch marked a significant milestone in space exploration. It has provided crucial data for various fields of astronomy, leading to some groundbreaking discoveries. The Hubble Space Telescope orbits Earth at an altitude of approximately 340 miles. And Hubble's orbit is carefully chosen to place it above most of Earth's atmosphere, allowing it to capture clear images of space objects. Now these space telescopes can capture clearer and sharper images, certainly than the telescopes that we have on the ground that we have been talking about. So, without the atmospheric distortion present on Earth, space telescopes can provide exceptionally sharp and high-resolution images of astronomical objects out there. The first successful space telescope, HST, was a joint project between NASA and ESA. The Hubble's Space Telescope was a collaborative effort between NASA from United States and ESA, the European Space Agency, demonstrating the international cooperation in space exploration. The Hubble's primary mirror has a diameter of nearly 2.4 meters, allowing for precise observations. The large primary mirror of Hubble enabled to gather more light, resulting in better quality observation and images. The Chandra X-ray Observatory, in another significant space telescope, it was launched in 1999. Chandra specializes in observing X-rays, which are emitted by extremely hot and high-energy objects in space, such as neutron stars or quasars. This Chandra observes X-rays, helping us study the high-resolution phenomenon in space. So, by detecting these X-rays, Chandra contributes to our understanding of violent and energetic events that are occurring out there in the universe. Infrared space telescopes like Spitzer Space Telescope detect heat radiation from the objects in the space. Now, these infrared telescopes, they observe the heat radiation, that is infrared light emitted by celestial objects. This allows astronomers to study objects that are otherwise invisible in the visible light. The James Webb Telescope, which is there in the space right now, it's highly anticipated infrared telescope, and it has already been launched in space. And this James Webb is the successor to the Hubble's Space Telescope, and is designed to operate primarily in the infrared part of the spectrum. It is expected to make groundbreaking discoveries, and it is making some groundbreaking discoveries. So this Webb telescope will operate beyond Earth's. It is operating beyond Earth's second Lagrangian point. The second Lagrangian point, or L2, is a stable location in the space where James Webb is positioned to maximize its observational capabilities. This L2 is approximately 1.5 million kilometers from Earth, providing a stable environment for the telescope. Placing JW at L2 ensures it is far from Earth's inference and offers a stable platform for observations. The Webb telescope's main goal is to study the universe's early galaxies and star formations. And JW its primary mission is to explore the origins of galaxies and the formation of stars and planetary systems in the early universe. And it has a 6.5 meter primary mirror and advanced instruments for infrared observations. Now, this James Webb telescope has a large primary mirror and state-of-the-art instrument, make it well suited for studying infrared emissions from the distant objects. The Kepler Space Telescope, which was launched in 2009, was designed to find some exoplanets. This Kepler's mission was to discover exoplanets by observing stars and detecting periodic dips in their brightness caused by transiting planets. Now, Kepler discovered the thousands of exoplanets by monitoring stars for periodic brightness dips. The data that was captured by Kepler has been crucial in identifying and characterizing thousands of exoplanets orbiting other stars out there in the universe. The Kepler mission has contributed significantly to our understanding of the outer planets, the planets that are outside the solar system. The Kepler's discoveries have expanded our knowledge of planetary systems beyond our solar system, which I was talking, and their diversity as well. The transiting exoplanets survey satellite continues the search for these exoplanets. This is all following. It's the mission from the Kepler, focusing and identifying the exoplanets and checking out the dips in the brightness of the stars that they are revolving around. That's what's becoming the most crucial things in evaluating these exoplanets that are out there in the universe. Now, talking about the Hubble Space Telescopes, they have made the deep field observations revealing distant galaxies. So Hubble's deep field observations involved long exposures to capture faint and distant galaxies, providing insight into the early universe. And Hubble's deep field images help estimate the age of the universe, right? So the deep field image allowed astronomers to to study the distribution and age of the galaxies in the universe, certainly contributing a lot to our understanding of cosmic beginning, or I should call it cosmic evolution. And talking about the wide field camera 3 on Hubble has been crucial for deep space observations. Abbreviated as WFC3 is one of the Hubble's instruments. It was basically designed for high resolution imaging across a wide range of wavelengths. Now, space telescopes, what they do actually, they observe various wavelengths, including visible, ultraviolet, X-rays, and infrared rays. And these space telescopes are equipped with multiple instruments to observe different wavelengths of electromagnetic radiation, certainly providing a comprehensive view of the universe. Another one is the Compton Gamma Ray Observatory. It was launched in 1991. Detected gamma rays bursts. The gamma ray bursts are among the most energetic events in the universe, and the Compton Observatory studied them to better understand their origins. The Fermi Gamma Ray Space Telescope, it certainly continues to study the gamma ray sources. The Fermi is a modern space telescope dedicated to studying gamma ray emissions from various sources, including active galaxies, pulsars. The Solar and Heliospheric Observatory studies the sun from the space. Its mission is to monitor the sun's activity, including solar flares and coronal mass ejections, which can impact Earth's space environment. And they also monitor solar activities and helps predict space weather events. Now, what about these space weather events? These space weather events can affect satellites, communication systems, and power grids on Earth, making observations crucial for forecasting such kind of events occurring there on Sun. The Planck satellite measured the cosmic microwave background radiation. So the cosmic microwave background radiation is the afterglow of the Big Bang and contains important clues about the early universe and the condition about the early universe, right? So this CMBR is a crucial for understanding the Big Bang theory and the data that can be collected on the basis of this CMBR. So observations of the cosmic microwave background support the Big Bang theory and providing an experimental evidence for the universe's origin. The Wilkinson microwave anisotropy probe also studied some cosmic microwave background radiations, it was from NASA, and it was about to study the variations in the cosmic microwave backgrounds, temperature across the sky. The European Space Agency's satellites precisely measure positions and motion of the stars, right? So what is it? It is GAIA mission. Its mission is to create a detailed 3D map of Milky Way by measuring the positions and motions of over 1 billion stars out there. This GAIA has produced a 3D map of over 1 billion stars in the Milky Way. GAIA's comprehensive stellar catalog has significantly improved our understanding of our galaxies, structure, and evolution. These are some of the important observations and some of the important instruments, the space telescopes that are out there, and they are taking all possible measurements and conveying us the happenings of the surroundings, the happenings in the galaxy, the happenings in the visible universe, and beyond.